Okay, today we're going to look at page 13 in your packet, and it is called Nomenclature Practice. Nomenclature is our way of naming ionic and covalent bonds. Okay, and what you should see is that on page 7, you should have your naming rules. So if I look back to page 7, what I see is that I have a chart with both of my ionic and covalent naming rules. Ionic bonds that have metals in them will be named by writing the metal first, then the nonmetal, and putting "ide" on the end of after the first syllable. Covalent bonds, where you see metalloids or nonmetals bonded together, we name the first metal, we put a prefix before it. We name the second nonmetal, and we put a prefix before it, and we put "ide" on the end. So with covalent, you will always have a prefix. The only reason you won't is if there is one element in the first spot. We never put mono in front of the first word. We can in front of the second, but not in front of the first. So if you see nonmetals, we're doing prefixes. If you see metals, it is ionic, and we're just writing the metal, the nonmetal, and IDE. So we're going to label each one of these as ionic. You need to do this in your packet. It is for a grade. So I'm going to label this as ionic because I see a metal first. That means I write my name of my metal, aluminum, my name of my nonmetal, and I put IDE, so oxide. All right, I see a metal right here, so I'm writing ionic out beside it. I'm naming it the same way, cesium, oxide. All right, now I see a metal here. I'm labeling it ionic, rubidium, oxide. Any one that you see that has a metal in it will be named that way. So for example, strontium, ionic, named the same way. This one is strontium, selenide. All right, the reason I skipped letter D is letter D starts with a non-metal. That's carbon. So when I'm naming this, it's going to be covalent. I'm going to add a prefix to every word based on what my subscript is. Here I only have one, and I can't put mono in this first spot, so I just write carbon. I see I have 4 hydrogens. My prefix for 4 is tetra, and then we put hydride. Now, every covalent bond should have a prefix in front of the second word. It should have a prefix in front of the first if there is a subscript, but if not, we just leave it as the normal element. So here, cesium, that is a metal, so ionic, cesium, sulfide. Okay, letter G is a nonmetal, so that is covalent. I only have one nitrogen, so I'm just going to label it nitrogen dioxide. Di is the prefix for 2, and I have 2 oxygens. Now, I'm going to skip down. You're going to do some of these on your own, but I am going to skip down to some of the more challenging ones, or ones that may be getting confusing. So, for example, I see silicon, and I see boron. Those are both metalloids. Our metalloids in this case are going to function as covalent bonds, so I'm going to write a covalent here. I'm going to use my covalent naming rules here. I don't see more than one, so I'm just writing silicon. I see 4 fluorines, so it's going to be tetrafluoride. Okay, right here I see 2 borons. All right, remember in covalent, a prefix goes before every single word unless there's one in the first spot. Well, now there's more than one, there's 2. So I'm going to name this diboron hexahydride. All right, so I think that should give you enough examples of ionic and covalent. The rest of them should be labeled I or C and should be named with the proper naming rules. If you have a question about that, all you need to do is look back at page 7 and some of our examples that we did following it. All right, if I turn to page 13, this is different, right? These are not the same as page this is page 14. This is not the same as page 13. On this page, we are going to be working on our finding our chemical formulas. This is not done the same day as page 13. So once you do page 13 right here, you will turn it in, get it graded, and we will move on to page 14 the next day. So if you have already gotten it graded, we will be on this page doing a few of the examples. Now remember, ionic and covalent, we find the formulas differently. If it's ionic, we have to drop and swap the charges. If it is covalent, we look at our prefixes only. So barium is a metal, so I'm going to write ionic right next to it. If it is ionic, I drop and swap the charges. What that means is that I look at the charge for barium, and I notice that barium is in group 2 and it has a positive 2 charge. Nitrogen is in group 15 and has a negative 3 charge. Now remember, in order to get full credit, you must draw your arrows. So when I swap them and drop them down to the subscript, barium gets the 3 from nitrogen, nitrogen gets the 2 from barium. All right, we have indium fluoride. Indium is in the same group as aluminum. It has a positive 3 charge. Fluorine has a negative 1 charge. It is ionic because we have a metal here. So I drop and swap my charges. So indium, In, gets the 1 from fluorine. Fluorine gets the 3 from indium. Calcium oxide. Calcium is a metal, so that is also ionic. Calcium is in group 2, it's a positive 2 charge. Oxygen is in group 16 and has a negative 2 charge. Remember, when it is ionic, if they have equal and opposite charges, we leave them off and we just write the symbol for calcium and the symbol for oxygen. Be sure yours are easily readable. Sodium, a metal, that makes it ionic. Sodium has a positive 1 charge. Nitrogen has a negative 3. Draw your arrows to show them swapping, and then drop them down to the subscript. Sodium gets the 3 from nitrogen, and nitrogen gets just a 1, so we don't write it. Boron trichloride. I see my prefix. I see a metalloid. This is covalent. I don't see a metal. So instead of doing anything with charges, remember with a covalent bond, all we do is use the prefixes. No prefix here, only 1. Tri means I have 3 chlorines. So these are very simple when they're covalent. So this one's covalent because I see nitrogen and oxygen. No metals, covalent. Nitrogen, I don't see a prefix, so I assume there's 1. Monoxide is the prefix for 1. So I have 1 oxygen. Covalent here, nitrogen and oxygen. I see a prefix. There will never be a prefix in an ionic bond. So dinitrogen monoxide means I have 2 nitrogens. Look back at your prefixes if you don't remember that. And monoxide means 1 oxygen. Covalent, again, prefixes mean it's covalent. No metals means it's covalent. Di and penta. So dinitrogen pentaoxide, N2O5. Silicone is a metalloid, but I know there's no metal, so I'm naming it covalent. Also, I see a prefix, which is not anionic, so that means it's covalent. Silicone, I don't see a prefix, so just 1. Tetrahydride means 4 hydrogens. Magnesium chloride. Magnesium has a positive 2 charge. Chlorine has a negative 1 charge. It's ionic. How do I know this? Because there's a metal here. So I'm swapping and dropping the charges. Magnesium gets the 1 from chlorine. Chlorine gets the 2 from magnesium. What I want you to do is I want you to be sure that you have them labeled ionic or covalent. And if they are ionic, you need to drop and swap the charges just like this. Yours needs to look identical to mine. If it's covalent, use only the prefixes. So this is ionic, potassium. Magnesium's a metal, ionic. Potassium's a metal, ionic. Sulfur. Sulfur's a nonmetal, covalent. Lithium's a metal, ionic. Oxygen is a nonmetal, covalent. Strontium. Strontium, if you look for it, is Sr. And when you find Sr, you'll notice that it is actually one of our group 2 alkaline earth metals. It is ionic. Aluminum, a metal, ionic. Calcium, a metal, ionic, so you're dropping and swapping the charges. Carbon, a nonmetal, covalent. Also, I see prefixes. Carbon, a nonmetal, covalent. Dinitrogen, I'm seeing prefixes and no metal, which means it's covalent. Iron is a metal, so ionic. Copper is a metal, so ionic. Lead is a metal, so ionic. Copper is a metal, ionic. Now, I do want to show you one thing. Down here at the bottom, you see these Roman numerals. We know that transition metals don't have specific charges. Their valence electron structure can vary. So whenever you're doing these, we know we have to drop and swap the charges in an ionic bond. This is ionic because they have a metal. So you have to be told the charge, and here are our charges. Metals always have positive charges. So this iron has a positive 3 charge, copper has a positive 2 charge, positive 4, and positive 1. So when you do this, you're taking fluorine, -1, oxygen, -2, fluorine, -1, and nitrogen, -3, and you are swapping them. So for iron fluoride, iron is Fe, it gets 1 from fluorine, and fluorine gets the 3 from iron. Copper and oxygen have the equal and opposite charges, so we just write CuO. Lead and fluorine have opposite charges. We have to swap them, swap and drop. So lead, Pb, gets a 1 from fluorine, fluorine gets the 4 from lead. Copper 1 nitride. Copper is Cu, and when we swap and drop the charges, be sure you are doing this, it counts. Copper gets the 3 from nitrogen. Nitrogen gets the 1 from copper. Okay, so I want you to be sure that you fill in the blanks.